Welcome to this video where we will look at the gradient of a linear graph. A linear graph is a straight line. That means when you draw the graph on a Cartesian plane using any method that you like, the sequence of points produced is a straight line when connected, something like that. We have our x and y Cartesian plane and the red line is our linear graph. We also have that the gradient of a linear graph denotes how steep it is or its slope. And there are four types of gradients we can refer to. There's the first type. If a line points from the bottom left to the top right as you move along the positive x-axis, then we say that the line has a positive gradient. If the line moves from the top left to the bottom right as we move towards the positive x-axis, the line has a negative gradient. A horizontal line in any position on the Cartesian plane has zero gradient, as you can see. And the fourth type, if we have a vertical line anywhere in the Cartesian plane, there is an undefined gradient. In fact, it is infinite. Now let's see what makes up a linear equation. In general, a linear equation is of the form y equals mx plus c. In this case, y and x are the variables. The letter m, which represents a number, is the gradient of the straight line. And the letter c, which also represents a number, is the y-intercept of the straight line. That means where the straight line intersects the y-axis. And you can see that on the graph on the right. Let's look at some examples. Here is a linear equation, y equals 3x minus 1. For this example, the gradient is 3, m equals 3, because it is the coefficient of x, and the y-intercept is negative 1. So we can write c equals negative 1. What about this equation? What do you think the gradient and the y-intercept is? The coefficient of x is negative 1, so the gradient is negative 1. We can always write plus 0 at the end of the equation, so the y-intercept is 0. Now if we have the graph of a linear equation, a straight line, and we want to work out its gradient from the graph, how can we do that? Let's suppose we start with the graph shown on the screen. The first step is to choose a point on the line and write down its coordinates. So the first point we will call A, and its coordinates will be x1, y1 as shown. So x1 is the x coordinate and y1 is the y coordinate of point A. Now we choose a second point on the line, let's call it point B, and write down its coordinates. In this case, we can write the coordinates of B are x2 and y2. The next step, imagine a right-angled triangle drawn underneath the line segment AB. The horizontal component or part of the triangle we call the run. The vertical side of the triangle is the rise. And from that definition, we can write down that the gradient of the straight line is equal to the rise divided by the run. That means if we know the two values, the rise and the run, we divide them, we take the ratio, and the result is the gradient of the straight line. And using the values x1, y1, x2, y2, the coordinates of the points A and B, we can write the gradient rise over run as m equals y2 minus y1 over x2 minus x1. So the run is x2 minus x1 and the rise is y2 minus y1. Let's try an example of this using actual numbers. Here is our straight line. We have 2 points already shown, A and B. First step, to write down the coordinates of points A and B. The coordinates of point A are negative 1, 5, and the coordinates of point B are 2 and 2. So writing down our formula for the gradient, m equals rise over run, and using component form, m will equal y2 minus y1 over x2 minus x1, and then substituting values for those, we have m equals 2 minus 5 over 2 minus negative 1, be careful with the two minuses, which comes out to be m equals negative 1. So the gradient of that straight line is negative 1. which fits in with our previous definition of the four types of gradient. You might remember the second type pointing from the top left to the bottom right as we go towards the positive x-axis is negative. I hope you enjoyed this brief explanation of some of the property of the gradient of a straight line, and please view the remainder of the videos relating to other properties.